Hello, welcome back to a brand new YouTube video. And in this video, we are going to be talking about exponent properties. Alright, so let's get started. So first, let's review what an exponent actually is. So let's say we have 2 times 2. Now that's easy enough to write out, but what if we want to do 2 times 2 times 2 times 2 times 2 times 2, and like this. Now, you may see the pattern here. We're just repeatedly multiplying the 2's together. So instead of just writing this all out, which takes some time, what we can actually do is write 2 to the 1, 2, 3, 4, 5, 6, 7, 8, 2 to the 8th. Now, but what does this mean? Well, this is actually a notation. This is like nothing, a new concept here. This is just notation. What 2 raised to the power of 8, or 2 to the 8th, is how this is read. What this really means is that we're taking 2, and then we're multiplying it together 8 times. So 2 times 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 2. Let's give another example. Let's say we have 4 to the 3rd power. Well, this means we're taking 4 and we're multiplying it together 3 times. So 4 times 4 times 4. And this is 64. Now, one common mistake people make is when they see 4 to the 3 power, they multiply these two together and they think it's equal to 12. But this is not the case. So just remember, you're repeatedly multiplying the numbers together. All right. Now, what if we have something else? Like, what if we have x, or maybe not x. Let's say we have like 2 to the 4th times 2 to the 5th. Now, you could do the math for all of this, but it will take a long time. So what's a shortcut we can do? Well, one shortcut we can do is, let's just expand this all out. So what's this? So 2 to the 4th is 2 times 2 times 2 times 2. Then 2 to the 5th is 2 times 2 times 2 times 2 times 2. A lot of 2's. But let's think, how many 2's are there? So let's see. The 2 to the 4th, that had 4 2's. And then the 2 to the 5th, that had 5 2's. So you have 4 plus 5 equals 9 2's all in all. So this is equal to, well, 2 multiplied together 9 times. All right, so you might see the pattern already, but let's do this one more time. So let's say we have 3 squared times 3. Oh, if it's raised to the 2nd power, it's often just said squared instead of 3 to the 2nd power, times 3 to the 5th. Well, this is 3 times 3 times 3 times 3 times 3 times 3 times 3. So there's 2 3's from 3 squared, and then 5 3's from 3 to the 5th. So all in all, we have 7 3's. So this is equal to 3 to the 7th. Now, what you might have noticed is that for 3 to the 2nd power times 3 to the 5th equals 3 to the 7th, what we're basically just doing is adding the exponents. And this isn't just like a conjecture or anything. This is like proven to be true. And it's kind of simple logic if you think about it. So the 3 squared, that's these 2 3's. And the 3 to the 5th, that's these 5 3's. So all in all, that makes 7 3's. 2 3's plus 5 3's makes 7 3's. So hopefully you see why that is the case. So let's just make a general rule here. Oops. Let's say we have x to the y power times a to the b. Oh, sorry. X to the z power. Well, this is x to the y plus c. So if we're multiplying two exponents and the bases are the same, this is important. If the bases aren't the same, if you have like 2 to the 3rd times 3 to the 5th, then we have 2 times 2 times 3 times 3 times 3 times 3 times 3. So we can't just combine this all again into like something else. So the bases must be the same. So if the bases are the same, like if you have x to the y times x to the z, that is x to the y plus z. So if we multiply exponents together, the exponents will actually add, which is kind of counterintuitive, but once you think about it, it kind of makes more sense. Now, one more thing before we get into some more exponent rules. Let's see what negative exponents mean. if we have a number to the negative first power, what does that mean? Well, you can't really multiply something negative times, so let's try a different example. Let's say we have 2 to the third power. This is equal to 2 times 2 times 2, or 8. And 2 squared. Well, this is equal to 2 times 2, or 4. Now 2 to the first. This is equal to 2 times, well, just 1, 2, so 2. Now, you might be asking, where are we going with this? Well, if you look, in each successive column, we're going down by 2. We're dividing by 2. And this kind of makes things sense when you think of this. 8, that's 2 times 2 times 2. 4 is 2 times 2. And 1 is 2. So we're removing 1, 2 each time. So we're dividing by 2. All right, so let's continue this pattern. If we have 2 to the 0th, we have 2, and then we just need to divide by 2 one more time. So we get 1. 2 divided by 2 is 1. Now this is interesting. We don't really think about to the 0th power, but if we have, let's say, 3 to the 0th power, well, that's just 3 to the first divided by 3, which is 1. So anything to the 0th power is 1. And to make that make more sense, if we have like 4 to the third, then 4 squared, then 4, it's dividing by 4, right? Because we're removing 1 4 each time. So if we have 4 to the fourth power, to go 1 less than this exponent, which is 1, we have to divide whatever this is by 4. And if you think about it, whatever this is, 4 to the first power is just 4. And we're dividing by 4. That's the thing. We're dividing by the base each time. So we're basically just dividing 4 by 4, which is 1. That may be a bit confusing at first, but if you think about it for maybe a couple of minutes, it should make more sense. All right, so now that we know 2 to the 0th is 1, that's not really what we're looking for. We're looking for negative powers, not 0th powers. So let's go down by 2 one more time. So 2 to the negative first, if we're going down by 1, we have to divide 1 and then divide by 2 again. So that's 1/2. All right, now one thing that may be a little counterintuitive at first is that 2, or not counterintuitive, but you may be wondering why we're doing this. But 2 divided by 1, that's just 2. So if we take 2 to the negative first, we're really just taking 2 divided by 1 to the negative first. And 2 divided by 1 to the negative first, that's just 1/2 from here, right? So we're basically just switching the numerator and the denominator. And that may be a little like, why is that the case? So let's see if we can figure out why that is the case. So basically, we're starting at 1, or let's say we have 2 squared. If we have 2 to the negative 2 power, then basically what we're doing is we're taking 2 to the 0th. If we have 2 to the 0th, and we want to get to 2 to the negative 2, so each time we divide by 2, we go down by 1. So we want to divide by 2 one time. So now this 0 becomes -1, but we want -2. So we want to divide by 2 again. Okay, but if you know a bit of, well, fractions, this can be written as 2 to the 0th. If we're dividing by 2, we're really just multiplying by the reciprocal, which is 1/2. So this is 2 to the 0th times over 2 times 2, or 2 to the 0th on 2 squared. So each time we go down by 1, we are dividing by 2. Okay, so 2 to the negative 2 power is 2 to the 0th divided by 2 squared. But what is 2 to the 0th? Well, 2 to the 0th is just 1. And 2 squared is just 4. Okay, now what does this really mean though? Well, 2 to the negative 2 power, that is just, well, we're taking 2 to the 0, or let's say we have a general thing. What if we have x to the negative y power? So we want x to the 0th, which is always just 1. And then we divide it by, well, how we need to get to the negative y, so we need to subtract, or we need to divide x, y times. So x divided by x divided by x, but this is just x to the 0th on, and if we're dividing by x so many times, then we're just multiplying by the reciprocal that many times. So we really are getting x to the 0th on x to the y. So x to the negative y is x to the 0th divided by x to the y. Well, what is x to the 0th? Again, that's just 1. So x to the negative y is 1 over x to the y. So what we're basically doing is we're taking x and we're flipping it around. The 1 on the bottom goes to the top. And then on the bottom, we're just taking x to whatever this negative was. So if it was negative 1, we do x to the first power on the bottom. Okay, so let's do a few examples here. Let's say we have 2 to the negative 3 power. Well, this is 2 to the 0th, and we're dividing by 2 3 times. So 2 times 2 times 2, which is 2 to the 0th on 2 cubed, which is 1 on 8. So 2 to the negative 3 is 1 over 8. Or we could use the shortcut like we found previously. And this is just 1 over 2 cubed or 1 over 8, so we got the same answer. So that's good. It's just a shortcut. Okay, so now hopefully you know how to do negative exponents. But if you don't, please just leave a comment in the description. Do not walk away from this video not knowing how to do any of these things. If you're confused, just leave a comment, email me, do any of that. Okay, so now that we've gone over negative exponents, let's go over one more thing. So we know how to multiply exponents, right? We just add the 3 and the 5 here. But what if we want to divide? Then how do we do it? Well, there's actually 2 ways we can explain this. And I'm just going to do what I think is the more intuitive way, which is just to do what we mentioned previously. If we have 2 to the 3 and we're dividing by 2 to the 5th, well, what this really means is that this is 2 times 2 times 2 times 2 times 2, or this is 2 to the 3rd divided by 2, divided by 2, divided by 2, 5 times. I'm not going to do all of it. So basically what we're doing is we're getting this 2 to the 3rd less and less powers 5 times. So we're reducing the power 5 times. So if we're reducing 2 to the 3rd's power 5 times, that's just 2 to the negative 2 power. Or, and if you don't see how I got this number, 2 to the 3rd reduced by 1, that's 2 squared. Reduced by another 1, that's 2 to the 1st. So reduced by a 3rd time, that's 2 to the 0th. Reduced by a 4th time, that's 2 to the 1st, or 2 to the negative 1st. And reduced by the 5th time, and that's 2 to the negative 2nd power. Okay, now we might be seeing how we can form a general rule from all of this. But let's do one more example first. Let's say we have 3 to the 7th on 3 to the 4th. Well, 3 to the 7th, we're just dividing by 3 4 times. So dividing by 3 once, that reduces it to 3 to the 6th. Dividing by, oh, this is not equals, this is divided by 3. We're dividing by 3 another time, this reduces to 3 to the 5th. And if you don't understand how we can reduce it like this, go back to the previous section. And we're dividing by 3 again, so that's 3 to the 4th. Dividing by 3 again, so that's 3 to the 3rd. Let's see, we've divided by 3, 1, 2, 3, 4. Oh, so that's our final answer. It's 3 to the 3rd. but we don't need to divide by 3 so many times. There's actually another shortcut we can do. But basically, every time we divide by 3, we're just reducing the exponent by 1, right? So, what we can think of this, if we're reducing the exponent by 1 4 times, because we're dividing by 4 times, we can just think as subtracting 4 from this. So 3 to the 7th over 3 to the 4, that's 3 to the 7th. And because we're dividing by 3 to the 4th, we're dividing by 3 4 times. So reducing the exponent by 1 4 times. So if we're reducing the exponent by 1 4 times, we're making the exponent go down 4 times. So we're subtracting 4. This is 3 cubed. And you can verify this yourself. 3 to the 7th is, well, I'm not going to do the math, but you can use a calculator to determine this expression and see if it's equal to this expression. All right, so this is just the first part in my exponent series. The next part in my exponent series will cover more exponent rules. Then the final third part in the exponent series will cover radicals. All right, so I hope you enjoy this video, and I will see you in the next one.